Well, hello there. We're going to have a very interesting look at some more measurement today, and in particular we're going to look at the area of areas and area unit conversion. Okay, this is very exciting. So, without any further ado, let's go. What have I got there? Well, I've got the key for you and me for area conversion. And it's very straightforward. In fact, it's identical in the structure and almost in the form of it to the length conversion little diagram that we have used in a previous lesson, except that all those conversion numbers that you see appearing along the top with the orange arrow steps and along the bottom with the green arrow steps are squared. They're squared. They're the same numbers, but they're squared, because areas are all about squaring lengths or multiplying lengths by lengths. That's where that squaring comes from. So let me explain to you what I'm talking about. Yes, that is the same diagram as we used for length, but the conversion numbers are squared. Why, oh why, you may ask. Well, I'll explain it to you. Have a look. There's a square, okay? A nice little square. Now that's a square metre. 1 square metre. You just have to imagine that it's a square metre, okay? Now, let's see if we were going to convert that. That's the height across the top. That's the height vertically. So the length times the width is the area for a square, okay? Or a rectangle, it doesn't matter. But anything with right angles in the corners, the area formula is the length times the width, okay? So that would be a square metre. If we wanted to convert that to square centimetres, what we do is we simply rewrite that length and width as centimetre dimensions, okay? And therefore, what do we get for the area in square centimetres? 1 square metre becomes 100 for the length times 100 for the width in square centimetres. Now we're beginning to see that's 100 squared square centimetres. So you can see, if to get metres into centimetres you have to multiply by 100, then you can see that because of the shape of a square shape or an area shape, to get from square metres to square centimetres, you've got the length and the width to be multiplying 100 each by, which gets you 100 squared. And the same thing applies for converting any area to another area. Even if it's a square shape or not, the same rules apply, and that's what is reflected in that diagram above. Now, wasn't that interesting? Yeah, squared, okay? That's right. Now you can see it's all making sense. Okay, yes, and we're very happy with a nice big tick, and let's keep going now. We're going to do some area conversions. Right, area unit conversion, and what do we want to do? Well, we're going to convert 2.39 kilometres squared into metre squared. I can smell a fairly large number coming up here. Let me show you how to do it. We just use the key. We start off with what we've got, and we say, looking at the key, to get from kilometres squared, which is on the extreme right hand side, to the left to square metres, it looks like we've got to multiply by 1,000 squared. Okay, now that means 1,000 times 1,000. Now goodness, how many zeros have we got there in that 1,000 times 1,000? Because that's how you work out how many spots to move your decimal point by. That decimal point sitting in between the 2 and the 3 is going to move to make that number much bigger. And when we make it bigger, we move the decimal point to the right. Okay, so we've got 6 zeros in 1,000 times 1,000. 3 for the first 1,000, 3 for the second 1,000, making 6 overall. Which, if you look at that number and put the commas in, you've got 1,000,000. So we're going to multiply that 2.39 by 1,000,000. So let's do it. Now I'm getting all my zeros all like ducks in a row ready to go. Now let's go. We've got 6 zeros or 6 decimal places to the right from that particular starting decimal point, which is between the 2 and the 3. So there's 1, 2, 3, 4, 5, 6. And see, I just put the decimal point in red. Now that's my new number. That's my new number. And I don't actually need those two decimal, those zeros at the end. They're kind of leftover ones. So my new number becomes, there it is like that. But I can just write it as 2390000 because they're 4 zeros, and with the understanding that that decimal point is just having a little sleep and is invisible behind the last 0. It's a whole number, and my units, you put the commas in, and the units are square meters. Okay, Mr. Box, thank you, Mr. Box, you're a star. Okay, now that was pretty straightforward. I'm sure you will agree, if you just take it slowly, anything is possible. Inch by inch, anything's a cinch, and mile by mile, life's a trial. Let's do another one. Same diagram. This time we're going to convert 658.796 millimetres squared to metre squared. Now, I'm sure you will agree that a metre is much bigger than a millimetre. So that means if we're going to put something that's a small dimension and we're going to put it into something which is much larger, express it in terms of a unit which is much larger, we're going to get less of them. Okay, we're going to get less of them. But if you're not sure about that, you just look at the diagram above. What have we got to do to go from square millimetres on the extreme left to square metres, which is the second from the right, or 2 over from the one on the extreme left? So that means we've got to divide. The yellow steps there are the ones we've got to go by this time to get 2 spots over to the left to the purple shape where we've got square metres. So let's do that. We'll use the above key, and we've got 658.796, and we're going to divide that by 10 squared to get the first spot over to the right, which is square centimetres. And then we've got to take that whole thing and we've got to divide it by another 100 squared to get to square metres. Goodness, all these squares are making my head spin. So, goodness me. Alright, well, look, why don't we just put all that dividing stuff in a big bracket on its own and try and figure out what it is, I think. Yeah, that's better, isn't it? So the 10 squared is 100 by 10 by 10, I mean, and the 100 squared is 100 by 100. So, come on now, count them up. How many zeros have we got in all those numbers, those tens and hundreds? 1, 2, 3, 4, 5, 6 zeros. So that means we're dividing by a 1 with 6 zeros after it, which means we're dividing by 1,000,000. So now when we're dividing a number, we move the decimal point to the left to make it a smaller number. So let's do that. Now I'm getting all my ducks in a row here. I need lots of zeros, and I'm going to move that decimal point between the 8 and the 7 6 spots to the left. Okay, here we go. 1, 2, 3, 4, 5, 6, and I've put the little red decimal point in. That's its new home. Okay, it's just moved house, and that is my new number. Now I don't need all those 3 zeros to the left of where that new decimal point is now, because they were just like, you know, in case I needed them. So we can re-express that. Usually we put 1 to the left of the decimal point just so that the decimal point doesn't get lost and you can't see it. That's all. So that looks like we've got 0.000658796, and what are my units? We've got to put those units in. I think it's square metres, isn't it? Yes, so there's Mr. Box. Hello, Mr. Box. We always love to see you. And that is my answer in square metres. Okay? Very good. Now, we're going on to the new area now. Oh, pardon the pun. Areas of some shapes. Let's have a look at each one in turn. Each one has a little code or formula for working out its area. Okay, the first one. First one is a square, and any rectangular shape, meaning with right angles in the corners, is the area is always the length by the width. Okay, so that's what we're looking at here. It's the space inside that is the area, and so that's what we do for a square. Thank you, Mr. Square. Now we've got a rectangle coming up next to that one on the right. So again, that's the length times the width, isn't it? Okay, and that's the area we get when we do that. We get the space inside, and it's always in square units, whatever those units are. Square millimetres or square centimetres or square metres, whatever the dimensions are given to us in, that'll be the answer. Okay, here comes a triangle. Now that's the formula for the area of a triangle is, oh, that one's done, yes, is half the base, which is the floor, and then we multiply that by the vertical height. That's when you make a right angle, like a wall to a floor. You know, you've got a right angle between them, and that's that one there. That's the vertical height. See the right angle between that height and the base. That's what you do, and you get that space inside, and that's that one done. Okay, all right. Well, we're going well here. Circle. Now that's equal to pi times the radius squared, where the radius is the distance from the circle to the outside. Okay, it doesn't matter which direction you go, as long as you go in a straight line, you'll always get the same length for the radius, and you get that space inside. Very good. Now, this next little beastie, oh, I think we're happy with the circle now. This next little beastie is called a parallelogram. A very, very funny name. It just means that the opposite sides are running in the same direction, like tram tracks or train tracks. You see, the top and the bottom are both going in the same direction, and so are the sides, although they're on a bit of an angle. So it's not a rectangle, is it? No, 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 it's not. It's a parallelogram. No right angles in the corners there. But the formula is very easy. It's basically the base, which is that, times the vertical height again. The same as we used in the triangle, okay? So the vertical height is that thing, okay? Now if you use that formula for a parallelogram, you will get its area. Voila! Very good. We're happy with that? Yes, we're delighted. Now this last one is a trapezium, okay? And that's a Latin word, by the way, a trapezium. It means little table. Don't ask me why it means that, but it does. Now the formula for the area of a trapezium is as follows. You add up the lengths of the parallel sides, A and B. You add them up, and you divide that by 2 to get the average, which is that's what the average is. It's half the sum of them. Take the sum, then halve it. You got the average. Then you multiply the answer by the vertical height again. So let's do that. It's half times, that's A, that one there, that's one of the parallel sides. There's B. You add them up, and then you take half of it. So that's why I've got them in a bracket. Add them up first, then take half of that, then multiply that by the vertical height, which is this one. Okay? If you do that, you get, add lengths of the parallel sides, divide by 2, multiply by the height, and Bob's your uncle. You get that one. I didn't colour it in because I'm just making too much of a mess. Okay? That's what you do. Alright, so this is easy, easy, easy. So let's go and do one now. Now, this is a triangle. But the funny thing about this triangle is the vertical height is actually outside the triangle. But fear not, this doesn't matter at all. Even though it looks like it might matter, we're not actually doing the area of anything outside those 3 lines which define the triangle. The formula is still the same, so you don't get put off by that. The area of the triangle is half the base, there's the base, I've just coloured it in purple for you, times the vertical height. And the vertical height is that thing, right? That's the formula, and you will still get the area of just the triangle, nothing outside of it. Okay, so let's do it. It's half times 88, which is the base, times the vertical height, which is 40, and if you put that into your trusty calculator, you'll get 1760. And what are your units? I ask you. Look at the diagram. You must put your units in, otherwise you are wrong. Okay, it's square centimetres, isn't it? Yeah, thank you, Mr. Box. We're done, and I think we've got another one here. Goodness, look at that strange looking thing. Now this is what I call a combined shape, okay? It's a hybrid, if you like, a combination of two shapes joined to one another, and it's not going to confuse us at all. Can you see what the two shapes are? Well, I'll help you. It's two shapes. The first shape is, what does that look like, that top bit? It's a half circle, isn't it? Of course it is. And that distance across it is the diameter, which is just means twice the radius. Okay? So that's no problem. So the diameter is the 50, so therefore the radius would have to be half of that. Yeah, that's the shape we're looking for the area of. Okay, coloured it in green hashing for you. Okay, and the other one is a square, because those sides are 50 millimetres, all four of them, with that little line that tells you that they're the same, that little dash that they put on across each side. Okay, well, this is no problem now. So the area of the half circle, remember now, the area for a circle is pi r squared. Okay, from the previous screen, but we haven't got r there, we've got d, so you've got to be jolly careful. It's pi r squared, but of course we want a half circle, so we've got to take pi r squared and halve that, because there's only a half circle there. Now, okay, let's go with that. R is 25. Now I'm just writing that in to make it perfectly clear that I'm not going to use 50 for r, because 50 is the diameter, which is twice r. Now let's plug away, okay? Yeah, not 50, don't go putting 50 in there, you'll get it wrong. There it is, so it's pi times 25 squared, and then we're taking a half of that. So what's my trusty calculator got me? 981.748, and I'll put the units in. I don't want to be messed up with units. It's square millimetres. Now, do you notice how I've got that to 3 decimal places? And the question, if you look at the question again, it's only asking you for 1 decimal place. But I'm deliberately not rounding that off, because I only do that at the end, because otherwise I lose accuracy. Okay? Okay, now that's our half circle. Now let's do the square now. The area of the square is the length times its width. Okay, that's the formula for the area of a square. And that's going to be 50 times 50, which comes to 2,500 square millimetres. Now, we're going to add up the area of the square to the area of the half circle, and we'll get our total area. There it is. Now I'm going to add that up, and I get that. 3481.75, but you'll notice that I'm only supposed to, now it's the time to round off now, so 1 decimal place, so you look at the second decimal place, and you see that's a 5. Now, if that second decimal place is 5 or above, in other words 5, 6, 7, 8 or 9, that means you put you round the first decimal place up 1, okay? If it's not 5 or above, you just leave the first decimal place as it is. So what do you think I'm going to do to that 7? Yes, I'm going to make it 8, and then forget about the second decimal place. There you are, and the answer is millimetres squared, okay? Do you get that now? Very good show. Alright, I think that's all for all that stuff. Now I think we've got someone to tell us that we did a good job. Hello, Mr. Penguin. Yes, thank you so much for your encouragement. We need that. Everybody needs encouragement. So I think we're pretty well done with that now. You feel good about what we've done? I do. Okay, well, thanks. You have a go at some now, and thanks for listening, and we'll see you again.